conspiracy after conspiracy coming to light.
Some of the most important discoveries in contemporary history have been made possible by CERN, the most sophisticated scientific research facility in the world. What if I told you, though, that there's something far worse going on beyond those closed doors? Today, we're delving into the startling assertions made by none other than David Icke, who feels that CERN experiments are endangering not just science, but all humankind. Prepare yourself, for what you are about to hear may permanently alter your perspective on the world. The goal of CERN is to discover the mysteries of the cosmos. The research done here is nothing short of groundbreaking, ranging from the discovery of the Higgs Boson to investigations into the fundamental structure of space and time. However, enormous power also entails immense responsibility, or in this instance, significant risk. Since its founding in the middle of the 1950s, the European Council for Nuclear Research, more popularly known as CERN, has gained recognition for its audacious experiments. Its revolutionary work has garnered much attention throughout the years, both favorable and bad. Some of its tests, meanwhile, have sparked concerns about possible hazards, including the creation of black holes or the disruption of reality. Upon its completion and operation on September 10, 2008, the Large Hadron Collider, LHC, became one of CERN's most renowned and controversial undertakings. The world's biggest particle accelerator, this enormous device spans over 27 kilometers and is outfitted with strong superconducting magnets. Particles are propelled to extraordinarily high energy as they speed through its tunnels by a number of accelerating devices. Even with its high price tag of more than $4.5 billion, many contend that the investment paid off. After all, the Higgs boson and many other hitherto unidentified particles have been identified, and the LHC has produced some of the most revolutionary discoveries in recent memory. Envision this: enormous apparatus propelling particles around its enormous loop at velocities nearly equal to the speed of light, doing more than 11,000 laps every second. It's a miracle of engineering and human intellect that opens doors to hitherto unreachable knowledge domains. The LHC generates a magnetic field within the accelerator that is almost 1,000 times greater than the Earth's magnetic field, using a number of strong electromagnets. When particles approach their maximum speed, nearly the speed of light, some are concerned about how this strong magnetic field can impact surrounding devices and possibly the Earth's magnetic field. These incredibly fast particles clash head-on, ejecting a burst of energy and other particles. The majority of the particles disappear in these fast collisions, few seconds at most. To catch every detail of these brief occurrences, scientists deploy specialized detectors surrounding the impact spots. It takes a lot of time and effort to sift through the enormous quantity of data produced by these collisions, more than 15 petabytes annually. An important milestone was accomplished in 2017 when the LHC stored more than 200 petabytes of data, or over 250,000 movies. But what precisely are academics seeking to find among all this data? Scientists observed an oddity involving a certain kind of quark. Small particles known as quarks comprise everything in our environment. They are available in a variety of forms, such as ice cream flavors, some of which are highly unstable and rapidly transform into other particles. They were interested in the beauty quark because of its extremely short half-life, which is only a fraction of a second. Beautiful quarks should normally decay into leptons, which are lighter particles that can be either an electron or a muon. Scientists had assumed that each would have an equal chance of occurring, but data from the Large Hadron Collider revealed something different. Approximately 70% of these quarks were becoming muons instead of dividing equally between electrons and muons. This anomaly points to a potential hidden participant in the equation, a strange particle that hasn't been observed by scientists previously. It's similar like discovering a missing piece from a puzzle you believe to be complete. Now, some scientists are questioning if this would indicate the existence of a completely new set of laws governing particle interactions, appending the physics community's accepted standard model. It's a fascinating idea that could provide answers to a lot of unanswered concerns regarding the cosmos. Discovering new physics is more ambitious than what the standard model can explain at this time. This model describes the behavior of minuscule particles in our environment, much like a blueprint. It contains almost everything known about the tiniest building components of nature, which makes it amazing. Despite its extreme precision, experts believe it to be incomplete. The strong force, the weak force, and electromagnetic are the three primary forces discussed in the Standard Model. However, it makes no mention of dark matter or gravity, the enigmatic substance that comprises the majority of the cosmos. Thus, during recent studies, scientists observed an oddity in their data. The data did not fit the predictions of the Standard Model. Strange outcomes are not unheard of, particularly given the volume of data coming from experiments such as the LHC. Yet this time, scientists became interested. They began to delve further in an attempt to ascertain what was happening. Their concept? Perhaps something quite else is at work here. It was dubbed Z-prime, and it could be transported via a brand new class of particle. Since there have been no prior indications of this force, it may be quite weak, but it might still account for this surprising finding. Though they are unsure of how this new force might interact with known conventional particles, the researchers believe it would behave differently with electrons and muons. It would be extremely significant for physics if researchers discovered new particles that carried this force. If this discovery is confirmed, physicists believe it will contribute to the resolution of major cosmic mysteries and provide an explanation for long-standing questions regarding dark matter and the function of the Higgs boson. It is thought by some scientists that this new force might play a major role in the unification of all fundamental forces in physics. Elon Musk claims that between 1998 and 2008, CERN built the largest and most potent particle collision in history, known as the Large Hadron Collider. Over 10,000 scientists contributed, in addition to several organizations and laboratories from more than 100 nations. It is located around 175 meters below the surface in a 27-kilometer tunnel that runs beneath the French-Swiss border close to Geneva. With an energy of 3.5 tera-electron-volts per beam, the first collision ever observed at the Large Hadron Collider was 4 times more powerful than the previous record. After the modifications were made, the energy in the Large Hadron Collider shot up to an astounding 6.5 tera-electron-volts per beam. Musk said that this enormous device is specialized in precisely smashing proton beams together. Interestingly, it can also shoot lead-ion beams, an accomplishment that happens once a year for a certain month. In order to confirm or refute the predictions of various particle physics theories, experts closely examine them during these sessions. The discovery of new particles predicted by subatomic theories and the puzzle of the nature of the Higgs boson are central to the purpose of the Large Hadron Collider. At this size, hadrons are the fundamental units of matter. They are complex structures made up of quarks joined by a strong force akin to the adhesive that holds atoms and molecules together. Protons and neutrons are well-known hadrons, but there are also less well-known ones like pions and kaons, whose existence was discovered in the middle of the 20th century by cosmic ray investigations. By bringing two opposing particle streams together, the LHC orchestrates a massive cosmic collision that makes it easier to investigate the elusive Higgs boson. Like waves in the water, this boson is an elementary particle entangled with the Higgs field. It appears as a ripple in the quantum sea. It is a new addition to the ever-growing collection of particles, apart from fundamental matter and without the quantum characteristics of carriers of fundamental forces like as nuclear interactions, the weak force, and electromagnetism. At the enormous research facility known as the Large Hadron Collider, the Higgs boson was found. This groundbreaking accomplishment occurred concurrently with experiments carried out by ATLAS and CMS, two significant teams. The revelation was announced on July 4, 2012, at the prestigious scientific facility CERN. The two most unusual decay pathways yielded the strongest signs for the Higgs boson detection at first. These decay routes included the particle either immediately converting into a pair of Z bosons, particles that provide a basic force in nature, or directly breaking down into a pair of photons, a process that is solely controlled by quantum mechanics. The Higgs boson's discovery did not, however, signal the end of scientific research. Instead, it sparked more research. The confirmation of the decay mechanism of the Higgs boson has been one of the most important discoveries since 2012. Leading this study, CERN predicts that searches for this elusive particle will be becoming more intense, especially in the third operating phase of the LHC. The high luminosity improvement, which is scheduled for completion in 2029, will drive this phase. With this improvement, the LHC will be able to perform more collisions, giving researchers more chances to find events that go beyond the assumptions of particle physics standard model. After the accelerator is updated, CERN predicts that it will create an astonishing 50 to 15 million Higgs bosons yearly, which is a significant increase over the 3 million that were produced in 2017. This production spike may be very helpful in differentiating between different Higgs boson forms. Up to 5 other variants of the Higgs boson are postulated by theories outside of the standard model. Some of these forms could be less commonly detected than the basic type. However, what's the big deal about the Higgs boson? The Higgs field plays a key role, particularly in the early cosmos. It creates the vacuum in which everything exists and determines the nature of space. Without it, the cosmos wouldn't contain mass in its minuscule building pieces, and there wouldn't be matter or the substance that holds everything together. The fundamental components of atoms, stars, and even life itself would not exist if the Higgs field and its particle, the Higgs boson, were non-existent. Because it was so difficult to locate, the Higgs boson came to be known as the God particle. Because it was so difficult to detect, a scientist by the name of Leon Lederman jokingly dubbed it the goddamn particle before the moniker became well known owing to the media. Despite some controversy between science and religion, the Higgs boson and its field are significant. He planned to refer to it as the goddamn particle in his book, but his publishers changed it to the God particle. They are necessary for everything to have mass. Without them, there would be no stars, planets, or even humans. There are 2 primary reasons why researchers are exploring the properties of the Higgs boson. First and foremost, they are eager to learn more about the early phases of the cosmos and the origins of the physical vacuum that surrounds our world. Their second area of concern is the mechanism by which this vacuum can continue to be stable throughout time. One unusual characteristic of the Higgs field is that it contains a potential energy that is always present and affects the physical vacuum. This distinct quality is essential to the formation of the cosmos as we know it. Researchers think that by comprehending and using this energy potential, basic forces like the weak force, which works over incredibly tiny distances, and electromagnetism, which spans eternally, may be explained. Scientists need to investigate the interactions between Higgs bosons in order to uncover these mysteries. To do this, pairs of these elusive particles must be created. Although the Higgs boson has shed light on how other particles get mass, its own mass is still unknown. Its mass cannot be guaranteed by theoretical symmetry, which might result in instabilities that cause quantum fluctuations to disturb the physical vacuum. Luckily, these disturbances occur over a longer period than the universe's known lifespan. Still, the search goes on. In order to stabilize the Higgs boson mass, scientists are searching for new particles that resemble Higgs particles. This quest fuels the need for deeper data analysis and, if feasible, access to colliders with greater energies. As a result, 10 years later, hundreds of committed specialists throughout the globe continue to work towards solving these puzzles. The mysterious particle known as the Higgs boson, which was initially proposed in 1964 and was only confirmed in 2012, has baffled scientists with its slow discovery. This delay is caused by the large mass and short lifetime of the Higgs boson. High-energy colliders were required in order to compress enormous quantities of energy into a small area in order to create such a large particle. After they develop, Higgs particles break up quickly into many pieces, only some of which can be distinguished from the background noise. Scientists build massive and complex detectors to identify these elusive particles, sorting through billions upon billions of proton collisions in search of the distinctive signatures of a Higgs boson. Conspiracy theories, however, are rampant among the scientific frenzies surrounding CERN's discoveries. There are many who cast doubt on CERN's genuine objectives, speculating that its experiments may open a portal to otherworldly domains. They worry that CERN may unintentionally unleash forces beyond human comprehension by manipulating subatomic particles at speeds that are unthinkable, plunging mankind into an apocalyptic state. CERN fiercely disputes such allegations, claiming that their search for antimatter seeks to further our understanding of the cosmos rather than call in the devils. In cosmological theories such as the Big Bang, antimatter, particles that have opposite electrical charges to ordinary matter, is thought to have been a crucial component in the origin of the universe. Instead than pursuing disaster, CERN's research projects aim to shed light on the riddles of life and get them one step closer to discovering the universe's secrets. The world's biggest particle physics laboratory, CERN, has a unique place in scientific fascination for antimatter, despite its rarity. The Mandela effect is a further intriguing concept that has drawn notice. This phenomenon explains the ways in which communal memory and real events might diverge. According to some theories, CERN experiments might cause broad differences in our memories, akin to the Mandela effect, and could even propel us into alternative realms. Conspiracy theorists have also been hearing rumblings of dark operations at CERN, including claims of human sacrifice. In 2016, a smuggled video supposedly captured hooded individuals performing a ritual, including graphic visuals of a kid suffering. CERN, however, quickly disregarded these allegations, claiming it was a manufactured joke. It's unclear if officials looked into this matter further. With its cutting-edge research and enigmatic atmosphere, CERN is a magnet for conspiracy theories. Online speculation spiked again in July 2022 when scientists reopened after significant renovations. In the middle of all the drama, it's important to remember that CERN's endeavors are based on science and are not the stuff of gloomy predictions. Rather of creating gateways to other worlds, CERN's investigations examine previously undiscovered physics while delving into the fundamental secrets of the cosmos. A startling discovery has been found by the Large Hadron Collider's forward search experiment detector. It has detected high-energy neutrinos produced by a particle collider for the first time. It detected 153 neutrino interactions with astounding accuracy, which is a noteworthy accomplishment in particle physics. This discovery clarifies the enigmatic processes of star burning and supernova explosions and opens doors to a fuller understanding of the tremendous neutrino interactions across the cosmos. It's critical to acknowledge the enormous influence that CERN has had on our comprehension of the cosmos, especially as scientists anxiously await more disclosures from this organization. Experiments at CERN continuously test our fundamental understanding of physics and push the frontiers of human knowledge, from discovering the Higgs Boson to locating elusive neutrinos. CERN's quest for knowledge is not without controversy, though. Some people believe its experiments are linked to malevolent operations or fear cataclysmic outcomes. Despite these reservations, the organization's dedication to expanding scientific knowledge for the sake of humanity is shown by professional debunking and scientific reassurance. In fact, CERN's efforts not only deepen our understanding of the cosmos, but also spur technological advancement and motivate scientists of the future as they consider the seemingly endless possibilities that lie ahead. Future findings from CERN have the potential to alter our understanding of the cosmos. CERN is at the forefront of research into the nature of spacetime, the mysteries of dark matter, and the fundamental forces of the cosmos. We are excited about CERN's amazing achievements and how they have increased our understanding of the cosmos, and we can't wait to see what else it will unveil. When we investigate the universe with CERN, who knows what groundbreaking discoveries are ahead? It's an exhilarating adventure, full of the excitement of learning new things and going beyond our preconceived notions of what is possible. We are getting closer to discovering the mysteries of the cosmos and comprehending reality itself with every experiment conducted at CERN. Findings that might fundamentally alter our understanding of the cosmos are made possible by the complex operations of the Large Hadron Collider and the meticulous data analysis performed by experts. In addition, the spirit of adventure that CERN embodies serves as an inspiration to scientists, educators, and enthusiasts throughout the globe. It highlights how vital it is to explore out of pure curiosity and seek information for the sake of humankind. These little subatomic particles, known as neutrinos, are produced by a variety of atomic processes, including nuclear reactions, cosmic rays, and even the radioactivity of bananas and potassium. Although they are abundant, they are nevertheless elusive, which has led scientists to refer to them as ghost particles. Scientists have been pursuing these elusive particles ever since they were discovered in 1956. 6 neutrinos were found in 2021, but it took another 2 years for scientists to properly prove their existence. Co-spokesperson for the project, James Boyd, a particle physicist at CERN, claims that research on these spectral particles can offer novel insights into deep space that cannot be obtained through other means. For particle astrophysics to progress, the search for neutrinos at the LHC is essential. Scientists hope to discover more of these spectral neutrinos and solve unsolved physics problems by collecting data through 2025. The scientific world is anticipating CERN's next revelations with great anticipation as they consider the significance of these discoveries for science's future. What are your thoughts about this CERN discovery that shocked scientists around the world? Share your opinions in the comments below. Thanks for watching another episode. While you're here, you can watch more space-related video.